On this problem, we're asked to find a polynomial function f of x of least possible degree having the graph shown. And then they show us this graph here. So I'm going to redraw the graph so that I can draw on it as I'm working the problem. So it crosses at -5 and over here at 3, and then it goes through a point up here at 0, 9. And our graph looks something like this. So in order to find the polynomial of least possible degree, well, we know that the polynomial function can be written as a leading coefficient, a, times the factors that produce this graph. Well, we can see from the factors from the graph that our x-intercepts are our factors. So the x-intercepts, the roots, the solutions, those can be written as factors by writing them in the form of x minus a, whatever that intercept is. And so here for x, for -5 of it as an x-intercept, that tells us that we have a factor of x minus -5, which would be x plus 5 when simplified. And same thing here at 3, we know that we have a factor of x minus 3. Now we also need to take into account the multiplicity of these factors. When the graph actually crosses the axis, like it does here at the -5, then we know that that point, that factor, will have odd multiplicity. And so because it actually crosses, it's going to have a multiplicity that is either 1 or 3 or 5 or 7. It's going to occur, that factor will occur an odd amount of times. Again, we want the least possible degree. So we're going to pick the least possible, the smallest odd, and would be 1. And so this factor occurs 1 time. So the x plus 5 occurs once. So x plus 5, or x plus 5 to the first power. Now, when the graph touches and goes back the way it came, when it doesn't actually cross the axis, it bounces like it does here at 3. That's considered to have even multiplicity, meaning that factor occurs an even number of times. So either 2 or 4 or 6 or 8. Again, to have the least possible, we're going to pick the smallest of those, which is 2. So we can either write it as x minus 3 times x minus 3 to show that it occurs twice, or that's the same as x minus 3 to the second power squared. So either way, we now know our factors. We know x plus 5 occurs once and x minus 3 occurs twice. So x plus 5 times x minus 3 squared would be the factors. The problem is there are infinitely many polynomials that have those as factors, but we're looking for the specific one that gives us this graph, which means we need to know the leading coefficient that affects this graph. So we know that a polynomial can be written as f of x is equal to a, the leading coefficient, whatever it happens to be, times the factors. So times x plus 5 times x minus 3 squared. But we need to know what that a is to know which particular function gives us this graph. So to find that a, we use another point on the graph. And so here we have this point 0, 9. And so that tells us that for this graph, when x is 0, y is 9. So we can plug in 0 for x and 9 for y. And when we do, the only variable we'll have is the a, the leading coefficient. And so we can solve for that to determine what the leading coefficient is. So we're going to plug in 9 for y is equal to a times, and then we're plugging in 0 for x. So 0 plus 5 times 0 minus 3 squared. Now we just need to simplify that to determine what a is. So simplifying inside our parentheses over here, we have 9 is equal to a times 0 plus 5 is 5 times 0 minus 3 is -3 squared. Taking care of our exponent, -3 squared is +9. So we have 9 is equal to a times 5 times +9. And then our multiplication there, we get 9 is equal to A times 45, or you can write it as 45 times A if you prefer, either way. To solve for A, we need to divide both sides by 45 to get the A by itself. And so we get A is equal to 9 over 45, which reduces to 1 over 5. And so now that we know what our A is, we can plug that back in to have our polynomial function. So f of x is equal to 1/5 times x plus 5 times x minus 3 squared. And that's the function that creates this graph. So we just need to plug that into our answer box in MyMathLab. So we're going to have 1/5 and then arrow over and then open parentheses and then x plus 5. We do not need to multiply that all out. We can leave it as factors. And then the other factor is x minus 3, and that one occurs twice. So we need to the second power. So we can use the caret key and put in the 2, or you could have used the power in the MyMathLab toolbox. Either way, we end up with that as our answer.